Okay, so we are going to look at some other things with quadratic functions today, or parabolas. Just a fun little thing to get you started here. If you look at this picture, it probably looks like it's moving, but it's really not. So we are first of all going to use our graphing calculators to help us today. I just want to remind you that when we did this yesterday, we learned about how to solve quadratics by factoring. And so just a quick reminder, obviously x times x makes x squared in the front. In the back, 8 could be 1 and 8 or 2 and 4, but in this case it will be 2 and 4. And if a plus is right here, it needs to be plus plus, or minus minus. This one will be plus plus. And then of course, and I know I'm doing this really fast, you'll go x plus 2 equals 0, so x equals negative 2. And x plus 4 equals 0, so x equals negative 4. I'm just showing you this because later on in the lesson, we are going to go from these points, and we're going to go backwards and go back and get the equation, the quadratic equation at the beginning, okay? Just so you know that. So we learned that one way we could find the roots of a parabola are to factor them, okay? Won't work every time, but oftentimes it will. And just a reminder that when it has an x squared in the equation, you know it's a parabola. It will open up if that number in front of the x squared is positive, and it will open down if the number in front of the x squared is negative. So in this case, we know it's a parabola that opens up when our x term is squared. And what we are looking for on the parabola is the two spots that the graph crosses the x-axis. We know that if it has an x squared term in it, it needs to have two roots to it, okay? And sometimes those roots are spots we can see where it crosses the x-axis, and sometimes those spots will be non-real roots or imaginary roots. And we will sort of talk about that later, okay? So we are going to get our graphing calculators here, and we are going to go to our graphing calculator, and just to help you with some troubleshooting, I'll do that along the way. We are first going to put in x squared plus 6x plus 8. So I'm going to get this in first, actually, before I forget this equation, and then I'll talk about troubleshooting. X squared, so x squared, notice I should start over. Notice I went to y equals, okay, right up here at the top of my graph. Then I'm going x squared plus 6x, and then plus 8. Okay, and to troubleshoot, I want you to scroll down here and make sure that you have nothing else in your y equals equations, because that will mess it up. And the other thing I want you to do is hit graph right now. Some of your graphs may not look like mine, and some of you may be getting some errors. So, two things I want you to do. If your graph does not look like mine, your window may be set different than mine. So I want you to press the window key up here. And actually, I want you to press the zoom key next to it. I want you to press the zoom key, okay, in the middle there where it's red on my calculator, and then press number 6 for standard. And now your window should be set the same as mine. If you're still getting an error, the other thing I want you to try is to do second y equals, and then I want you to press number 4, which says plots off, and then hit enter until it says done. And that may be giving you an error as well, okay? If those things are not working for you, then you'll have to wait until I can look at your calculator, but hopefully that will help. Okay? Anyways, we've gotten our equation in. We already know that that graph has roots of negative 2 and negative 4. We can see that on the graph, that it crosses the x-axis at negative 2 and negative 4. So we know that this particular parabola has two real roots, because there are spots we can see where they cross on the x-axis. And then what I want you to try first of all, to figure out exactly what those numbers are, is to use your table, okay? So you're going to go second graph up here, and I want you to use your table, and what you're going to be looking for on your table are the spots where your y value is 0, because if it crosses the x-axis, that means you went left or right so much and not up or down at all, so your y value would be 0. And so if you use your table, you can use your arrows, and I'm going to look for where my y values are 0. I know from my graph that this one has 2 of them, because I can see it crosses the x-axis in 2 spots. One here at negative 2, and one here at negative 4. And we already knew that because we factored this one. So I know that it is negative 2 and negative 4. Okay, so we are going to look at some other situations. All right, now we're going to put this this equation into our calculator. It has to be set equal to 0 first. So I'm going to add 4 to both sides. So I have x squared minus 4x plus 4 equals 0. And this is the equation that I'm going to put into my calculator. Again, before you even put it in, you should be able to tell me that it's a parabola because it has an x squared in it, and that it opens up because that number in front of your x squared is a positive 1. So I'm going to go to my calculator. X squared minus 4x plus 4. Okay, y equals, clear this one out. X squared minus 4x plus 4. And I am going to graph that. And I'm going to clear this ink layer off so that that's not so annoying. Here what happens is that parabola is supposed to have 2 roots, but it only crosses the x-axis in one spot. And when that vertex hits exactly on the x-axis, it's what's called a double root. It actually looks like it only crosses in one spot, but it is called a double root. And I'm going to show you why when we factor this. If we were to factor this equation, you would have x times x, and then 2 times 2, and minus and minus. See how you have 2 of the same factors, and when I set them equal to 0, I get x equals 2, and I get it in both places. Okay? So when that happens, if you look at the graph and it only crosses the x-axis in one spot, your answer will be like this: x equals 2, and then I want you to write double root for me. And if you want to abbreviate that as dr, that's fine. Okay? And again, if I go back to my calculator screen, I can see it crosses in one spot. I'm going to hope it crosses at a whole number because then my table will be helpful for me. So if I go over here to my table and I look for where my y value is 0 on my table, you can see your y value is 0 obviously right here at 2. And we already know that that's what happens. Okay? Here's another situation. X squared minus 4x plus 5. So if I put that in, x squared minus 4x plus 5, I'm going to press y equals x squared minus 4x plus 5. Okay? And I hit graph. Now this is what my parabola looks like. And again, I would know it's a parabola because it's an x squared. The number in front of that x squared is positive, so I would know it opens up. However, in this case, the parabola does not cross the x-axis at all. Okay? But I know because it has a square in it that it needs to have 2 roots. But since it's not a spot where we can see it crosses the x-axis, you are going to write this: 2 non-real, or if you want to write imaginary, that would be even better, 2 non-real, and I'm going to put imaginary in parentheses, roots. That means that the roots have eyes in them. Okay? If it's non-real or imaginary, the roots will have eyes in them, and we will look at in the next few days exactly how to find those roots. But that's what you will write if it doesn't cross the x-axis for today. All right, then I'm actually going to go back to this calculator screen, and I'm going to put one more in that is not on your note sheet, but I want to give it to you anyways because I want to show you sometimes what happens. All the examples I've given you so far are spots where they cross the x-axis in a whole number. And sometimes they won't cross the x-axis in a whole number, and then you need to do something different. So I want to show you what that is. Okay, so I'm going to do 6 x squared plus x minus 2. Okay, and I'm going to hit graph there. So this is a parabola that I can see has 2 real roots because it crosses the x-axis in 2 spots. It's not a double root because it's 2 different spots. But I know it has 2 real roots, and I need to find what they are. So I first try to go to my table. Okay, and when I go to my table, I'm looking for where my y values are 0. And the problem is I don't have it. I know it's got to occur somewhere in between here because my y value jumps from negative to positive there, but I'm not seeing where my y value is 0. And I could play with my table and set its increments, but that's actually kind of more of a mess. So here's another tool that you can use, and you can use this tool all the time, even when it does cross the x-axis in whole numbers. I want you to go back to graph for right now. And what I need to do is I need to find out what that spot is right there. I know my y value is going to be 0 at that spot, but I don't know what my x value is. So another way you can do this is you can go to calculate, which is second trace. Okay, second trace. And then you're going to look for 2, which is 0. You're going to look for the 0 function, which is the number 2 option on mine. Okay, then notice down here your calculator screen is asking you to tell it what the left bound is. What that means is it wants you to put the cursor, use your left and your right arrows, and put the cursor just a little bit left somewhere of where that red dot is. So put the cursor a little bit left of the red dot and hit enter. Now you know your calculator screen is asking you for right bound, so now it wants that cursor a little bit right of that red dot and hit enter. And now it's asking you for a guess, which means it wants you to put your cursor as close to right on to that red dot as you can get, and you won't be able to get it exactly, but put it close and hit enter. Okay, and you can see that obviously my y value is 0, but my x value is 0.5 or 1/2 at that spot. So there's the first spot that it crosses the x-axis at. Okay, now I'm going to put a blue dot here, and I'm going to do the same thing. Okay, so I'm going to go second trace, number 2 for 0, and left bound means I need to have my cursor a little bit left of the blue dot, hit enter. Right bound, a little bit right of the blue dot, hit enter. Guess, right on the blue dot, and hit enter. And you can see that that root is -2/3. Okay, your calculator's spitting it out as a decimal, but it is -2/3. Okay, so that's what you're going to do if it doesn't cross the x-axis in whole number increments. All right, now you guys, we're going to go backwards, and I'm going to give you roots, and you're going to give me the equation. Okay, so if a root is 1/2, what I know is that x minus 1/2 equals 0. You know that. And if I have a root of -5, I know that x minus -5 equals 0. Okay, remember it's always the opposite sign, or this is x plus 5 equals 0. Okay, then you can multiply those two together, and I can go like this. X minus 1/2 times x plus 5 has to equal 0 for the quadratic equation. Okay. Then I don't really like to deal with fractions, so I am going to multiply this quantity by 2, and I'm going to multiply this by 2. Well, 0 times 2 is still 0. And now I need to distribute this through, and if I distribute that through, 2 times x is 2x, and 2 times -1/2 is -1. And I don't want to distribute it through again, because if I multiply this by 2 again, that means I've really multiplied by 2 twice. I've multiplied by 2 and then 2 again, which means I've multiplied by 4, and that's not what I'm doing here. So you really only need to multiply it through one parentheses. All right, then you're going to FOIL this out, and if you FOIL this out, 2x times x is 2x squared. 2x times 5 is 10x. -1 times x is -x, and -1 times 5 is -5. Okay, and then obviously you can combine these two, and you're going to get 2x squared plus 9x minus 5 equals 0. So this is really what I'm looking for. This is what the equation for the parabola would be, or the expression of it. Okay? All right, and we'll hit one more here just so that we can talk about fractions. Ooh, I should go back to this one, you guys, and show you the graph. My roots look like this. I can see from my equation that it is a parabola that opens up because this number is positive. And if I go back here and hit graph, this is what the graph would look like. So it does cross the x-axis at -5 and at 1/2. All right. Here's another one. It has a root of -1/3 and -2. So x minus -1/3 equals 0, and x minus -2 equals 0. And again, I'm going to go boom, boom. So x plus 1/3 times x, and then this is boom, boom, plus 2 equals 0. And you could go right to that step for me if you want to. You don't need to write all that minus and negative business out, but just to show you why that happens. Again, I don't really like fractions, so I'm going to multiply this side by 3 and this side by 3. And if I distribute that through, 3 times x is 3x, and 3 times 1/3 is 1. And then I have x plus 2. I'm not going to distribute the 3 through that parentheses because then I would multiply by 3 and then 3 again. And then 0 times 3 is still 0. FOIL this out, and you will have 3x squared plus 6x plus x plus 2, or 3x squared plus 7x plus 2. Okay, now, I know that I have two real roots. They're negative 1/3 and negative 2, so I know it's a parabola that crosses the x-axis in those two spots. I know it opens up because my a is positive. I know it's going to be a skinnier parabola because I've got that 3 in front of there. And this is what it would look like. All right, then if you have a double root, what that means, again, and we talked about this before, is that you actually have the same thing twice. So I have x minus negative 4, and I have x minus negative 4. And obviously that becomes x plus 4. Okay, FOIL that out. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. And then of course you can simplify that, which you probably already are doing. So x squared plus 8x plus 16. And again, when you know it's a double root, you should know that it is a parabola that only crosses the x-axis in one spot at negative 4. And you know it's a parabola that opens up. So just so you know, it will look something like this. All right, and then our last one. Here you can see that I'm giving you imaginary roots, okay? I'm giving you imaginary roots. So what you need to do, and this is why I kept showing you that minus business before, because you're going to need it here. Here you're going to go x minus the quantity 1 plus 2i. Okay? And then you have to go x minus the quantity 1 minus 2i. Okay, now what happens is that negative needs to get distributed through here. And so you'll have x minus 1 minus 2i. And x, and then if I distribute this one, minus 1 plus 2i. Okay. Now you get to distribute this and FOIL it. And by the way, you guys, with imaginary roots, you're always going to have a partner. So if it only gives you 1 plus 2i, you know it has to have a partner of 1 minus 2i, a conjugate partner. Okay? That will always work with imaginaries. All right, so distribute this. So x times x is x squared. X times negative 1 is negative x. X times 2i is 2ix. Okay? Moving on. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times 2i is negative 2i. And moving on. Negative 2i times x is negative 2ix. Negative 2i times negative 1 is positive 2i. And negative 2i times positive 2i is negative 4i squared. Okay, so the beauty of this is that these two will cancel each other out, and these two will cancel each other out. And now what I have is I can combine some things, and I have negative x here and negative x here. So I have x squared minus 2x plus 1 minus 4i squared. And we know that that I squared is negative 1, so this is really minus 4 times negative 1, which is really plus 4. Okay, so then I have x squared minus 2x plus 5. And that's what I'm looking for there. And if I go back and show you the graph, and I know this is kind of a mess, but obviously it does not cross the x-axis because it has imaginary roots. So that's what that would look like. Your assignment for today then is objectives 77 and 78, and hopefully this will go okay.